All right, welcome to the Civboot podcast, episode 3, where I'm going to talk a little bit about the software stack for the Civboot, or the possible software stack. This is actually something, sorry about the delay since the last episode, this is actually something I've been working on pretty intensely ever since I discovered a programming language named Forth and a project called CollapseOS, where he's managed to get an entire operating system, text editor, cross-compiler, etc., running on Forth with only about 5,000 bytes of code. A few thousand, like 1,000 lines of assembly and a few hundred lines of Forth, and you have a full stack. This is really exciting to me for the prospects for CollapseOS. It demonstrates what's possible with very minimal hardware. So I'm going to talk about that. And the reason I'm talking about this instead of my planned episode of talking about chip fabrication technologies, which I think is interesting and I think we do need to talk about soon, but I just want to show that you don't need the hundreds of megabytes, hundreds of gigabytes that modern processors, modern computers have in order to rebuild the foundations of civilization, have basic automation, design tools, text editors, communications, networking, etc. I think a lot of the stuff that civilization, that are the quote-unquote foundations for civilization's technology, don't depend on the large amount of hardware. In particular, I think this is best demonstrated with Forth. I'm really excited about the Forth language. Now, Forth, as a programming language, it can spin it itself up. It can walk very early. Only a few thousand lines of assembly. Because the language has essentially no syntax, it's just white space and characters, essentially. As far as syntax goes, it's very easy to write a basic interpreter in assembly, and then the rest of the language can be written in Forth. And that's very useful for Civboot because somebody trying to understand our technology obviously needs to understand assembly, needs to understand how a computer talks or how a computer works, which requires understanding assembly. And so understanding assembly is needed anyway. And so only a few thousand lines of assembly, and you can write the core interpreter and everything for your Forth. It's great. Now, Forth is commonly criticized as what's called a write-only language, meaning you can write Forth and do it pretty well, and it's very interactive. It's very fun to write, actually. I've actually had I've been really enjoying writing Forth, but it's very difficult to read because you kind of have to keep this whole stack in your head. The way Forth works, it's a stack-based language, so each word that's executed pulls things off from a data stack and then pushes new things onto the data stack so that the next word can then be executed with the alterations made. And you kind of have to keep the whole stack in your head. You don't have local variables and stuff as much in Forth. Now, you can add local variables. So to prevent, because I want to build software that's understandable, I've been thinking about how to redesign Forth a little bit without any overhead, no runtime overhead, and very few kilobytes of compiler time overhead. Compile time. It's kind of an odd word in Forth, actually, but that you could add a type system. And I'm currently working on that. I'll have more. It's not really ready for public perusal, but you could look it up. It's called typeforth.org. I should have something more concrete in the future. But all of that aside, this Forth, the language, is so minimal and can bootstrap itself so quickly you can actually understand the full stack. Now, I want to compare this a little bit with modern software. Modern software, like a C compiler, for instance. You might think C is a very simple language, maps very quickly to the low-level details, but C compilers are enormous. Now, people have written bootstrap C compilers in pure assembly. They're typically larger. C has way more syntax than Forth, so it requires a lot more complexity to write a simple language. And then the C preprocessor, which is what the macro system is implemented in, that's actually more complicated than the language itself, from my understanding. And C without the preprocessor is a much more difficult language to write complex programs in. So the preprocessor is important. The macros are important. And so I think with type forth, I can achieve a language that's as expressive as C. Doesn't quite get the runtime performance. I mean, forth is very fast, but it's 30% cost compared to handwritten assembly or handwritten highly optimized C. So then that's okay. A Civboot doesn't have to have perfect, high performance code. So that's in modern C implementations typically are large compilers, and very few compilers can be bootstrapped from just assembly. And that's, I think, essential for Civboot. You have to be able to, there should be no binaries required to download in order to build a Civboot. And actually, on the point of performance, Forth code runs best on a stack-based CPU instead of modern complex instruction sets using registers. A stack-based CPU simply does the same thing as Forth does. It has instructions, only a few instructions, and those instructions take values off the stack and push values onto the stack. Very simple, and that basically can map directly to Forth. So you could actually get pretty good performance out of Forth if you use a stack-based CPU instead of the modern CPUs. And to that point, stack-based CPUs are very, very simple. I don't believe the CollapseOS CPU is a stack-based CPU, it's the Z80. But just for illustration, that CPU is only 9,000 transistors. 9,000. The largest CPU currently has more than 30 billion transistors. Just think about that. 30 billion transistors. Imagine the complexity of that. It's not understandable by any single person, certainly. 9,000 transistors, you could understand that given enough time. And lest you think that you can't create such a CPU using such minimal tools, the creator of Forth, Chuck Moore, has managed to build a full VLSI, that's a computer chip designing software, emulation software in only around 12 kilobytes of code. He has a company called Green Arrays. They build their own computer chips. They're highly scalable multiprocessor, very simple chips that basically run Forth. It's impressive stuff. It's as a demonstration, especially, that you can achieve much more simple software, much more simple hardware. It's really exciting stuff. Before I saw this, I thought I might be a little crazy. That maybe this was really, really impossible. But with this, I really feel like it's possible. I think you can write readable software that boots itself in only a few thousand lines of assembly. Essentially, you could have a hex dump. If it's a simple CPU, you could read the hex and boot Forth, which is pretty incredible. Yeah. So, exciting stuff coming. This hopefully helps you give you a picture of what the hardware needs to look like for a Civboot. It doesn't have to be super complex. The J1 CPU, which actually was designed specifically to run Forth, it's only 200 lines of Verilog, which is a hardware description language. I think you could probably literally hand wire it with like transistors and mux chips and stuff, if you wanted to. You could hand design it without even using any software at all. So I think this stuff is very possible, and I think it's very exciting. I also want to put a disclaimer that this is not, in my opinion, this is not my criticism of modern software development. Modern software development relies on encapsulating complexity. So you have tiny pieces, you have the complexity encapsulated inside of the software component or library. It has a clear API, and then you can build pieces using the encapsulated pieces. You layer complexity. You have a complex operating system that gives you what you need. You write software that targets that operating system and has guaranteed security features. The operating system does. And the operating system provides memory, easy memory access, etc. And Civboot won't have a memory manager that can provide more than like a kilobyte blocks of memory. But the memory manager will be really simple to design and really simple to understand. There's trade-offs in software. And some software, a lot of software needs to have those layered complexity, especially when you're first trying to develop complex systems. It's important to be able to layer your complexity. A Civboot is taking what's complicated, all this great stuff we've discovered in software, design processes, ways of thinking about solutions to problems, taking all of it and reducing until it's understandable. That's not a criticism of the complex stuff. You needed to have the complex stuff to be able to reduce it to the simple stuff. Going from physics, you needed all of the researchers who discovered all the properties about electromagnetism for Maxwell to come along and define a single equation that unified all of the different equations around electromagnetism. It was more complicated before Maxwell. Maxwell made it simpler by making a single equation. That's what I want Civboot to be. I want it to make a simpler stack. And you could build more complexity on top of it, make things that aren't Civboots. You could use the ideas in Civboot along with more complex software. This isn't a criticism of open source. This isn't a criticism of Linux or other operating systems. Those are all great. But in order to have it all packaged into a system that only a few hundred people, given only 4 or 5 years, could understand and rebuild and improve upon, you can't have all the complexity that modern software development has. And that's okay. You can have both. And they can build on each other. And that's the purpose of a Civboot. So hopefully I'll do an introduction to the programming language I'm writing at some time soon. And also we should get to the production of computer chips sometime soon. I'm really interested in that as well. So with that, thanks for listening. And I'll see y'all later.